okay, let's learn how to do this now using sklearn's linear regression, time for the machine learning. So let us create a new header. We'll call this machine learning. Dun, 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 dun. Very exciting. Linear regression. Okay, by the end of this lesson, you are going to enter the population of people who have built machine learning models. So it's very exciting. Okay, so how do we do this? First thing, like above how we use the sns.reg plot, we're going to use the sklearn library. So we're going to import linear regression. So from, okay, so it's in the sklearn.library, sklearn dot, and what it is, it's a linear model. Okay, so you can see the option there, linear model, and that's where linear regression lives. So we are going to import linear regression as one word. See how it's one word here? Okay, you don't have spacing, right, when it's an actual Python object. Okay, so that's the model we're using. Great. What is next? Okay, next we initialize the model. I'm going to put out the steps since this is our first one. Write them down. So these are generic. Import the model. Okay, next step, initialize model. Okay, so how do we do that? Well, we've got that linear regression, we need to use it. So we just set it equal to model. And when you write it out as is, you're basically declaring, hey, we're using linear regression, right? We haven't put in any data with it. We're just saying that's what we're doing. Okay, we're doing linear regression, and we've established a variable called model, okay, whose type here is going to be, excuse me, a linear regression sklearn model. Great. Next. And this is where the magic happens, okay? So it's kind of amazing. It's one line of code. We're going to fit the model to the data. Or does it fit data to the model? No, it's fit model to the data because what's happening is the following, okay? Let's get the code up first. It's model.fit, okay, parentheses. Okay, so no, we're not setting anything equal to, right? Now that we've got our linear regression object, we have a method .fit, and we want to do the capital X lowercase y. We're fitting X to Y. So this is where all the magic happens. Now, let me quickly just sort of explain to you what's going to happen, and I will put it underneath here in a coding cell. I just want to get the data up. Okay, so what's going to happen with this .fit? Okay, these are the inputs, right? All of these except for the median house value. And so what is going to happen in that line of code? Each of these are going to get random multipliers, and they're going to add them all up. That's what linear regression does. It multiplies and adds to see how close it is to this median house value. And because they're randomly initialized, it's going to be bad. And so it's going to check and be like, oh, that's really far off. You overshot by a lot. Lower your values. And it's going to go back and forth. Those are called iterations. I don't know how many it'll take, maybe 100 iterations until it converges upon ideal fits. Okay? It's built into linear regression. This is called back propagation. It goes back and it updates the weights based on what's called gradient descent, which is minimizing the error. So first you get a bad error, and then you adjust, using calculus or just by comparing the error. There are different methods, and you eventually get as close as you can to each of these rows. Recall there are 17,000 rows here. And so after this line of code, you have a model that is fit to your data, okay? So basically the machine learning is done, and so what then? Okay, you've got a model, then what? It's not going to do anything or show you anything. You want to know how good is the model. So a good model or a bad model. So what you want to do next is score the model. And for now, we'll just do the regular model.score and see how it did, okay? And it'll actually give us a score. Now the score that's going to give us is R2, which basically tells us more or less the interpretation is the percentage of data that is explained by the model. You can just think of it, the closer to 1, the better. The closer to 0, the worse. It's kind of similar to a percentage in that regard. So those are the lines of code that you need. You can see it's only 4, and that will build a machine learning model and give you a score to know how good it is. So let's run this wonderful code together and see what happens. Look how fast that is, okay? Remember I was telling you it's gonna like go back and update itself maybe 100 times to kind of converge upon these ideal weights. We've got, so 64%. So basically it says that 64% of the data is explained by this model. And I would say that's solid, okay? It's not ideal, it could be a little better, but it's pretty good for a first try.